Very good afternoon to everyone. So we bring to you a small webinar on data analytics using R. So thank you all for joining. So this is a very brief session of just about 1 hour, out of which 10 minutes we are going to keep aside for your questions and answer. So here it is not a deep dive session. We are going to do an overview. We are going to talk about a few commands in R for data manipulation. We will look at a few visualization forms offered by R. We will touch upon K-means clustering, and then we will open it for Q&A. So that is the agenda. So I'm just going to move to the next slide. And this explains what we're going to cover in this 1 hour duration. Why learn R? So here we will talk about the various features of the R language, a few basic commands for data manipulation, few basic commands for data visualization, K means clustering, and then we will talk about the data analytics using R, the book. So let's get started. So here we have a small little diagram which explains why you should learn R. The first thing, R is free and open source. It is a very powerful statistical computing programming language. You can perform complex calculations. You can do your analysis. In case you're interested in data science and would want to deep dive to understand your data sets, you can use R. So if you look at here, it says you can have fun with statistics. Of course, it is free and open source. You have great visualization supports. So not just the normal chart forms like bar chart, line chart, pie chart, scatter plots, but you can also look at some of the advanced visualizations. You can look at a box plot where you can compute the 5 magical numbers. You can also look at something like a curve, a strip chart, etc. You can also draw a heat map. So those are some of the visualization forms that we will discuss. It, of course, has cross-platform compatibility. So you can be on any operating system. You will be able to get a compatible version of R to work with that operating system. So you can be on Windows, you can be on a Mac OS, you can also use Linux and so on. It has easy extensibility as well and integration with other programming languages such as Python, C, C++, C#, etc. You have a great supporting open source community. So watch it for the new versions which keep evolving. So every year there will be about 2 releases of R where they add more features. So this is in short why you should pick up R. Just to talk about from where R has originated. So we had a language called as S. This was a language by AT&T, which is now the Lucent Technologies. So R is greatly inspired from S, which means whatever you could do in S programming language, you can still run that in R and several things beyond it as well. So yes, the origin has been the S programming language, but it has grown, it has evolved over the years. And now it is one of the most powerful statistical analytical computing language. Let's look at the next slide. Here we're going to talk about a few basic commands for data exploration. So guys, I have just picked about 5 or 6 basic commands. I am not going to be executing it in the R interface, but what we have done is we'll talk about what the command actually is. We'll show you the syntax, and you can see that we've also pasted a screenshot which will help you understand the output and also comment on what you're seeing in the screenshot. So the first command that we are going to talk about is summary, right? Which means that once a data set is given to you, or if you're working with a data set which is inbuilt provided with R itself, you should be able to understand what this data set is all about. And 6 of the parameters that we usually look at. Now, when you look at data set, we are basically concerned with the numeric columns. So I would want to know what is the minimum value, what is the first quartile or 25 percentile. I would want to know the median and the mean. I would also want to know the third quartile and the max, right? So those are the 6 magical number summary that I would want to be shown to me for each of the numeric column. So here you can see in the example, what we have done is we are using an empty cars. Now this is a already provided internal data set from R. So this is about some 32 observations, which means we are looking at some cars way back in 1970s, and we have some parameters under which it has been providing the data, and we are evaluating each of the numeric column for these 6 magical numbers: minimum, first quartile, median, mean, third quartile, and maximum. So this is just a snapshot view of what your data is all about. That's why it's called as a summary command. Next, when you look at STR, the word STR has come from structure. So here we are going to look at the internal structure of the data set. So what I'm doing here in the examples is I'm using a data set which has been provided with R. So empty cars is a data set provided with R. So here you can see that we have 32 observations. So guys, 32 observations means 32 rows. That means we have data for 32 cars. And then we have 11 variables. Variable here means the columns. So we are going to get information for 11 column values. So when I say STR empty cars, it shows me the internal constitution, the internal structure. The data set is comprised of what values under what headings. That is what is explained here. So you can see that we have column names like MPG, which is miles per gallon. We have cylinders, we have disp, we have HP, etc., etc. So these are the various column names. We have the data types of the columns which are displayed here. And these are the values which are available in each column. So 32 observation, meaning 32 rows, 11 variables, meaning 11 columns. So this is again a way to understand your data set. It's all about interpreting your data set better, make sense of the data. Let's move on to the next command. So this one is called as the view command. One thing everybody should understand here is R is highly case sensitive. So when I've put that as a capital V in view, it has to be written as is. It cannot be spelled with a small v, because then you will get a syntactical error saying that this command is not available in the R library. Right? So R is highly case sensitive. So here it means that you are going to get a spreadsheet view of your data. Guys who are coming from the RDBMS background, we are used to seeing data in rows and columns format. So if that is how you would want your data to be shown to you, you can always type in a view. Now, this is not an editor. This is just a viewing screen. So you can see that we have about 32 observations. I have just displayed a part of the data set, and we have about 11 variables here under which the data values are displayed. And this here is the name of the various cars for which we have collected the data under these headings. So that is your view command. So this is all about understanding your data. You start with the structure, which is nothing but the schema. We look at the data types, we look at the number of columns, and then we look at the values which are held under each column. Let's move to the next one. This is about head. Now, guys, if you just want to look at the top few rows, etc., we can go with the head command. So here it says head, and look at the syntax. You are supposed to specify the data set as the first parameter to the head command. Here, n is equal to 6. That means how many rows are you interested in? When I say n is equal to 6, it means that display the top 6 rows, right? So by default, it will display the top 6 rows if you omit out the second parameter. But if you want to specify any other number, for example, if you're interested in viewing the top 10 rows, you can say n is equal to 10 and so on. So this is just to get a snapshot of the data which is held within your data set. And this data set could be any data set one which is supplied with R. It could be a user-defined data set as well. So these are the two parameters that we have used here, and you can see that 6 observations or 6 rows are being displayed, and those 11 column values. Likewise, just like you have a head command, we also have a command called as tail, which means this is going to show you the last n observations. N meaning the number of records that you want to view, observation meaning the rows. So here, the data set and n is equal to 6 means from the bottom, from the last record, go upwards and extract out the last 6 rows from your data set. Right? So these are the last 6 rows that you have from your data set. So head, tail, summary, str, we've done these commands, and of course the view one. Another one for data exploration is the end row. Now, in case you want to find out the number of records, now why would you look at head and tail? Guys, we know that when you are taking up analysis, etc., we end up with huge data sets which has about hundreds and thousands and millions of records. And it can also be very overwhelming. So if you just want to understand, you would just want to look at a for which your head and your tail command comes in handy, right? And summary, of course, will give you a snapshot view of what your data is composed of. STR talks about the internal constitution, shows you a list of values for you to understand better. Now, end row would give you the number of observations which are there in your data set. Observation is another term for records, for rows. That is your end row, n meaning n is the number of records. And likewise, you have an n col, which means the number of variables or the number of columns. Columns here are referred to by the term variable. So here it says we have got 11 variables. So those are the 11 columns under which the values have been collected in the data set empty cars. And this is a provided data set. So as is, you will be able to run these commands if you have an installation of R. So the book has the very first chapter, which shows you the various steps of installing R onto your machine. It's a very small step, just about a couple of clicks. If you're doing a window installation, it'll ask you for whether you have a 32-bit OS or a 64-bit OS. So be a little careful when you specify the version which has to be installed on your machine. Likewise for Linux and Mac machines as well. So once you've done that, you should be good to try out these commands. It also has a very, very powerful help feature. So there are a lot of help documentation available. So check out the syntaxes for these commands. And this is not just these commands that we have shown you, but there are n number of commands which will help you with data manipulation. So the first 3 chapters in the book will have a number of commands covered. We have explained the syntax. Every parameter in the syntax has been explained with examples. So check that out as well. Now let's move to a few basic commands for data visualization. Guys, today is the age of infographics, which means graphs which are meant to convey information, right? So here we are focused on data visualization. Yes, there are very powerful visualization tools available in the market. We have both proprietary licensed tools and we also have some of the free tools as well. So in case you are looking at delving deeper into the data visualization, you can look at tools like Tableau, ClickView. There is also the SSRS SQL Server reporting services from Microsoft. You can look at IBM Cognos. You can also look at something from SAP, which is called as Business Objects, a MicroStrategy, etc. But if you're looking at the open source, you have Pentahold reporting. And you also have something called as Jaspersoft, n number of reporting tools available in the market today. But R also comes with a rich repository of chart forms, etc., that you can explore here, right? So R is powerful in 2 ways. One, it has got statistical capabilities built within because you can perform very complex calculations here. Second, you can also use it to plot various beautiful visualizations, which helps the understanding of the data set. Another thing to mention here is R has also been integrated with Tableau. Now, Tableau is the world's leading data visualization software, but it is only for data visualization. And Tableau, to get you the analytical abilities as well, has integrated ours. If you look at Tableau version 8 onwards, you will have this tight integration with R, which means for all the back-end computation, for all the analysis, Tableau pushes it to R. R does all the calculations and statistical analysis and pushes the data back to Tableau, where you can visualize the data. But you don't have to really go for a market leading reporting tool, because R itself is powerful in terms of its visualization capabilities. Right? So here we're going to start off with a very, very simple syntax. That's the plot command, right? So guys, let's have a look at the syntax here. I've put 3 commands on the lines. One is S, and then we've written something like a less than sign followed by a hyphen. This is for assignment. This is your equal to sign. And what you are assigning is basically an array or a vector. So C stands for concatenate, and then we have some values in here. We've got 5 values. So these 5 values become the value for S. S is a vector, and we're just displaying the values here. Now for the plot command, the first parameter is the vector S, and we know what it is constituted of. It's got 5 values, a 75, a 65, a 65 again, a 57, and a 60, etc. And then we say type is equal to H. Now there can be several values for the type parameter. H means histogram. Histogram means vertical lines, as you can see here in the screenshot. Main means the main heading, right? So that's the overall title for this plot. That's your main heading, and we've put that as histogram. And you can see that pretty much here in the diagram, that you get the title as histogram. LWD means the line width, which means how fat do you want these lines to be, right? So line width is set to be 4 here. You can always go for a lower value. If you want thinner lines, you can increase the value in case you want larger or thicker lines, right? COL. Now, please do not read this as column. This stands for color, and the color is black, right? And you can see that we've got 5 values in here. So therefore, you see these 5 lines in here, right? So this is about the plot command. This is the start of your data visualization journey, right? And H here stands for histogram. So that's the first command that we've done under data visualization. Let's look at the next one. This stands for hist. So if you don't want to use a plot, you can always use a hist command. So here again, we are creating a vector first. Now, how am I doing this here? I'm actually reading data values from a CSV file, which means a comma separated value file, and I'm storing it into a vector. So the second chapter in the book talks about the various different input sources, for example, a CSV, an Excel sheet, a text file, etc., and RDBMS as well. How are you going to get data from any of these data into your vector? We also have a section which has been devoted to reading in data from a NoSQL database. Now, NoSQL means not only SQL database, and we've covered 2 there. We have MongoDB, which is a document-based NoSQL database, and we have another one which is column-oriented data store called as Cassandra. So we have also shown you how to read data from MongoDB and Cassandra and bring that data into R for analysis. And then again, we're just displaying the values which have been imported from a CSV file into the vector in R. And you can see that we've got 4 observations or 4 of these rows here. And we have some of these columns here. So you can see that we have something called as a name, and then we have January, February, March, April, May, and June. So that's basically the attendance record for students. So we have actually explained where you can get these data sets as well. So mostly we have explored our commands using the provided data sets from R. something like trees, which is a provided data set from our empty cars. But some places we've also experimented with smaller data sets, which I have created, and you can also leverage the same. Then we have gotten into the hist command. So now you can understand that main here is just to give an overall title to this visualization, and the color is gray, right? So here you can experiment with the various colors and so on. And you can see that we have plotted the values for the very first vector, which is your S here. So that's the syntax for hist command. So guys, we have actually explained a few parameters of each of this command, but again, the commands are very, very powerful, has got n number of options, n number of parameters, and I'm sure that you will explore it on your own. So this is just to provide you with a basic start and insight, right? As I mentioned, this is not a deep dive into R, because 1 hour is too short a time to cover all of the beautiful features that R language comes with. So we are just getting you a head start into R here. Now let's move to the next one. And this one is a command called as pie. Now guys, we are all aware of the pie chart. Just a couple of pros and cons on using the pie chart. So guys, whenever you think about visualization, don't always think about the pie chart, right? So we've also given tips in the book which states that when are you supposed to be using which chart form. Now, just to give you a little clue on that, if you are looking at a relative comparison, right? Assuming there are 3 companies and you want to know which company is doing the best, the suggestion has to be coming for a bar chart, right? Bar chart shows you the balance looking at companies and what percentage you have something like a part to a whole relationship, and you would want to be interested in viewing that, you can go for a pie chart, right? Again, if you have a data which is split into more than 6 categories, a pie chart is a strict no. So which means if you have data which has been classified or categorized into 3 or less categories, or let's say 6 or less categories, yes, you can go in for a pie chart. But in case your data set can be classified into more than 6 categories, 10 classes there or 15 classes there, you should not opt for a pie chart. You should go in for a bar chart or a stacked bar. So these kind of useful tips on which chart form to use when has also been stated in the book. And by the way, once the survey was done by the data visualization experts, and what they found was pie chart is the most abused chart in the world. Any place that people think about data visualization, the first chart form they think about is the pie chart, which is not correct, right? So just be a little cautious about this fact that every place, every chart form cannot be used. There are specific situations which will demand that a particular chart form be used. For example, if you're looking at relationship between 2 variables, a scatter plot is supposed to be the best one because you get to plot the correlation coefficients and stuff like that. If you are looking for the changes as it happens over a period of time, you should go in for a line chart, right? If you are looking for understanding your data set, you're looking at the 5 magical numbers to be plotted, you should go in for something like a box plot, right? If you are not concerned with the actual specific data values, but you just want to know at a glance which region in the world has got the highest rainfall, which regions are causing a cause for concern, etc., then you should go in for a heat map and so on. So these kinds of tips have been given in the book as well, right? So here what we are doing is we are creating a vector B, and here you can see that we've pumped in a few values. This is the way you do it. This one, as I explained, is your assignment operator. It is an equal to operator. So you can also use an equal to in place of this operator here, right? And then we say a pie chart. So pi is supposed to be the command. B is the vector here. Main is to give the overall title to this chart form, which is my pie chart. COL, that is not to be interpreted as col. It is not column, but it is for the color. And here we say rainbow, and I've given the length of the vector. And you can see that we've got 7 values. That was intentional because I'm looking at 7 weekdays to be plotted here. So rainbow, which actually fetch 7 colors in the rainbow. Therefore, you see this as a very, very colorful chart. Now, pie chart, one of the distinguishing feature is supposed to be the color, right? So that is supposed to be one of the uniqueness of the pie chart. With bar chart, we don't ask you to experiment with color. I don't want to see a bar in a different color each time that you move from one bar to another bar in the same bar chart. You can have the same color for all the bars in the bar chart because there the distinguishing factor would be the length of the bar, either horizontal or vertical, right? Labels is equal to, now it is self-explanatory. Label here means I would want to look at a name for each of these slices, the pies in your pie chart, right? So we've labeled that as a Wednesday, a Tuesday, a Monday, etc., etc., right? So that is your pie chart. So that's another chart form that we've discussed here. The next one that we're discussing is the box plot. Guys, this is also referred to as a box and a whiskers plot. So this central area that you see here, it can be shaped like a square or it can be a rectangle, right? So this is your box here. The line that you see in the center is the median. Now we go with median as giving the correct average, not the mean value, the median, right? And this line that you see here and the line that you see at the bottom, those are referred to as the whiskers, correct? So why is the box plot becoming so very popular these days? So it is not new. It has already been in existence for 20 plus years. But of late, people have started using box plot in most of the visualization that they plot, especially with statistical and analytical analysis, right? The first thing, it quickly helps you see the outliers. So something which doesn't fall within the whisker and the box is considered to be an outlier. If you have too many outliers in your data set, right, it means that your data is impure. So you have to write back to the person who's managing your data source saying that you will have to send me clean data, because if the data itself is impure, you cannot have a good visualization, right? The other thing about the box plot is, and why it is becoming so popular, is it is also about the skewness, which means it tells you about the symmetry ratio. Is your data symmetrical? If you get a median right in the center of the box, it means your data is symmetrical. That means equally poised. You have the same number of values on either side of your median value. If it is skewed towards the left or skewed toward the right, you will have to take that into consideration. So this also talks about the skewness, right? So when to use your box plot, etc., has also been explained in the books with several examples. We've taken a data set, we've looked at the left skewness, we've looked at the right skewness, and so on. So we talk about the symmetry of your data set. This is all about understanding your data better, right? So that's on your box plot. So guys, the bar that you see at the top, that's your minimum value. It gives you 5 magical numbers. The first one is minimum. The second one is the maximum, right? So before you start to analyze your data, please arrange it in order, either in ascending order or a descending order. That way it will be easier to spot the median value, right? So the minimum, the maximum, and the median, those are the 3 values. Then we go with the first quartile and we go with the third quartile, which means I am interested in knowing the 25th percentile and the 75th percentile. The data which is to be taken for analysis is the middle 50%. Your outliers will usually be in the first 25% or the last 25% of the data, correct? The middle value is supposed to be the best value to be taken up for analysis. And that is the 50%. That is why we say the box is actually the 25 here and the 75 here. So that is the 50th percentile, which is to be considered, right? So ignore the first 25 value because here it could be having outliers. and also ignore the topmost 25% of the value, because there is also the place where you can have outliers, right? So this, in a quick glance, will be able to show you what your data set is and how it has been arranged. So this is on the box plots. We've done a bar chart, we've done a pie chart, we've done a histogram, and we've spoken about the box plot as well. So again, guys, as I mentioned, we don't have too much of time to delve deeper into the various forms of visualization. But when you read the book, we have a complete chapter devoted to the various type of visualizations and also the pros and cons, when to use which one. So that's where you're going to get those best tips and tricks to help you visualize your data better. And guys, please remember, the age is of infographics, right? Graphs are meant to convey information. It is not just one fancy item which will appear on your screen. It has to make sense, right? Okay, so the next one is about k-means clustering. Now, before I start to explain the k-means clustering, let me talk about the other chapters that are there in the book. So guys, we also have something on regression. We have covered linear regression. We have also got a chapter, an exclusive chapter devoted to logistic regression. We speak about the decision tree. We've covered some other data mining algorithms like market basket analysis. We talk about k-means clustering. We also looked at the big data and parallel computing angles and so on, right? And we have a chapter which is devoted to clustering as well, right? So guys, what is k-means clustering, right? What is a cluster? So for a novice, for a layman, if I have to explain, I would say a cluster is a group, right? It is a class. The first thing that you read here in the slide is k-means algorithm is an unsupervised clustering method. So what is the meaning of unsupervised? So guys, when you look at data science, there are three kinds of algorithm that we study. We have supervised, we have unsupervised, and we have something called as reinforcement learning. This is a way that AI, your artificial intelligence machines would learn, right? What is the meaning of unsupervised? It means unguided, without guidance, right? Which means the data set that I am evaluating is without labels, right? It is unlabeled, it is unclassified, it is uncategorized, right? And I'm going to do that without any guidance. I will explore and learn on my own. So when your machine starts to learn on their own, they will experience it, they will further evolve. That is called as unsupervised learning. When you say supervised learning, it means I'm going to give you a set of instructions. That means that's the input. And I also tell you this is the output which is expected. So when I do that, if I tell you the response that I'm expecting, we say this is supervised learning. Reinforcement learning goes a step beyond the unsupervised learning, which means I'm not going to give you anything. You learn from the environment, right? So, for example, a child, when the child is starting to learn to walk, right? They also do that on their own without the guidance. So if parents or the elders are not around, they still would want to stand up on their feet and walk. Now they've seen that the elders first have to get up. If they're seated, they have to first get up, steady themselves, take the first step, and one step at a time, the left leg forward, the right leg forward, and so on. So if the child watches and learns, we say this is reinforcement learning. We didn't provide the input, we didn't provide the output. It's experiencing and learning. May fall on the way to learning, but that is all right, correct? That's called as reinforcement learning. K-means clustering is totally unsupervised clustering method, right? What we have to do is we've been given a data set which has n number of observations or rows. And it's totally unclassified, it's totally uncategorized, it's totally unlabeled. So what is it that we do? What we are going to do is we are going to assign them to clusters or groups. And when you do that, you have to make sure that the values which fall in one cluster have similarities, right? And the similarities are very strong that they could not have been placed in another cluster, which is very different from the members that they have in their own cluster. For example, if no, we have to classify trees, the various types of trees and the various kinds of animals, I can just go with two clusters first, saying that, okay, we recognize that no, we have to have legs to walk. So that can be one category. So all animals, whether it's dogs, cats, your elephants, etc., all can be in one group. And then the trees, etc., which do not have legs per se, will be in another group. So that's one way of classifying. So, like that, you can think of several examples where we are not giving you any specific output, but you are going to explore it on your own. So, here, the main thing is how do you classify your data so that the data which are in the same cluster are very similar. I'm not saying same, I said similar, right? Because of some features, some traits, and the similarity is very strong as compared to what you're going to see in another cluster, right? So they're very different from the members that you have in the other cluster and very similar to the people that they have in their own cluster, to the data members that they have in their own cluster. So here K stands for the number. How many groups, how many clusters do you want your values to be placed in? So if you want that to be in 3, we say we want it to be divided into 3 clusters and so on, right? So here, guys, the first thing, if you look at the syntax, is the very first parameter says that that value has to be a matrix. So if you look at the screenshot, the first thing is we are creating a matrix of values. And you can see that I have created a 4 cross 4 matrix, which means 4 rows and 4 columns. I have about a 1:20. That means I will use about 20 values to place into this 4 cross 4 matrix, 4 rows and 4 columns matrix. Once I have done that, I am going to give you the k-means command. The first parameter, as we explained, is a matrix, after which we said, how many centers, how many clusters do you want? And we put the number as 3. And this command or this function will return a few outputs. The first one, it's going to give you a mean for every cluster. So guys, if you just look at the screen here, the screenshot, it says cluster means. Now we said 3 clusters. You can see that 1, 2, 3 as the row number. Those are the 3 clusters. And then how many columns did we have? We had 4 columns. So each cluster will still go with 4 columns and we have the mean values for that, right? Then it is also going to give you the clustering vectors, how many values have been placed into each cluster and so on. And it gives you some of the components, some of the available components. So as you start to look at the output, now spend some time, people say that how do you interpret the output? If you are looking at the interpretation, the making sense of data, you will have to really study the output very well. So just don't flash a command and wait for something to be displayed, but try to interpret every line of what has been shown as an output to you. That'll help your understanding of the data value. And guys, just one more tip here. There is no end to analysis. An analysis leads to further analysis, and that leads to further analysis and so on. You might have to draw a line saying that I am good with this much, right? And if need be, you might have to go deep down, correct? So that's on the k-means clustering. So once we've done this, this can be understood. This kind of an output is understood very easily by the developers community, people who are working with R, they are technocrats, they are into technology, and I will be able to interpret the output, right? But the business users, right, for whom you are doing the analysis, they may not be so much into technology as how you are. Now, if they are very much technology savvy, that is a bonus to you. But if they are not, you are supposed to show it to them in a form that they are easily able to interpret. Why? Because they are the decision makers. They are the ones who are supposed to evaluate the same thing and then take decisions based on what you are showing them as a report, as a visualization, etc. So once you've done your analysis, please follow that up with a visualization. So here you can see that we have split that into 4 clusters, and you can see that these are differently colored here, right? So these are the mean values that we have plotted here. And you can see that in the syntax, I'm using 2 more things here. We have a PCH and we have a CEX here. So PCH actually stands for the symbol. What kind of symbols do you want to use here? So I've just gone with a circle and a filled circle for that matter. And the CEX would mean that what would be the scale? How much do you want it to scale? If you want very, very small dots to appear for each cluster, then you can reduce the CX value. The default is 1, which is 100%. But if you say 1.5, it will scale it up 50%. If you want it to be scaled down, you can say 0.5% and it scales it down. That means you will have very, very minuscule dots displayed on your visualization screen, right? So we've just done one of the data mining algorithm, K means clustering. But in the book, we have a chapter devoted to decision trees. We have one chapter for classification. We have another one where we explore the a priori algorithm, which is on market basket analysis, your associative rule mining. And we've also done a little experimentation with your big data and stuff like that, right? So there are n number of algorithms covered. Also, of course, we've spoken about the regression part. There is a chapter exclusively on your logistic regression, a chapter on linear regression, etc. Right? And then we have done a lot of examples there. We have also given a lot of check your understanding kinds of question in case you are reading it on your own and you want to self-assess. It'll help you. We have also given a few of those lab exercises. Some are solved and some are unsolved. So people who want to take it to the lab and get the students to do hands-on, they will find it useful as well, right? And as I mentioned before, R is a very, very robust open source community and things are evolving on the fly, right? So next 6 months, you should be hearing about a new version of R as well. So I'm open to questions. In the meantime that you put questions for me in the chat window, this is how the book looks like. It's already available in the market, right? So the name of the book is Data Analytics Using R. It is a big book. It goes beyond the 500 pages. It's got 12 chapters. The first 2-3 chapters are devoted to understanding what R is. It talks about the installation of R on the various operating system platforms. We have given you screenshots on and guided you through the steps of installing R and the various packages. It's got a very rich repository of more than 2,000 plus libraries. We've told you how to make use of that because today the world again is of reusability. So there is no point reinventing the wheel. You can write your own functions there, but the ones which are already existing, maybe that can help you with your problem, right? We have got a chapter devoted exclusively to data frames because that's, again, one of the most important data types. So we have a chapter on the various data types supported in R. We also are looking at something with respect to the various data visualization stuff that we have, also the various data mining algorithms and so on, right? We have a chapter on parallel computing as well. Read up the book and I think Magro Community is there to help you with where you can procure the book, etc. But I think it's available on Amazon as well as Flipkart, etc. So most of the leading booksellers will also have it. So do get yourself a copy and explore, and we're open to feedback. And wherever you need help, we are there as a community to help you as well, right? Okay. So this was, in short, a very brief overview about the book, and we've covered some excerpts from the book. We did not do a lot of a deep dive, but we have just given you a head start. This was just meant to create the awareness about the R language. We've just explored a few commands for data manipulation, a few commands for data visualization, and I just spoke about the K-means clustering, right? The commands and the syntaxes which have been given in the book, they are all tried and tested. You can directly lift it from the book and place it at the command prompt and execute it without any changes, right? So that is about the book here. Okay, so guys, I'm open to questions. We have about 10 minutes, and let me see. If you have questions, I will take it up and try to answer it to the best of my ability. So guys, R is very, very extensive. So you can also split. I mean, in case you are from a college and you're looking at introducing this as a semester course, etc. The entire coverage, it's a very extensive coverage. As I mentioned, 12 chapters with a lot of hands-on, and the more you explore, there will be still more to explore. So you can also split that as a 2 semester syllabus, right? In case you need help, etc., you can always words to macro, and we will see how we are going to leverage that as well. Okay, so somebody has put a question saying that advanced analysis covered in this course. We are sticking to doing the data mining algorithms. So logistic, linear, decision tree, classification, clustering, market basket analysis, etc., have been covered in pretty much detail. We've also given you pointers in the book to look at some of the advanced the analysis as well. So there is food for thought. We have left you with pointers on where you can pick up more. Some places we've also mentioned the prerequisites, saying that you will be better able to appreciate the topics at hand if you've done this already. So if there is a prerequisite required, we have clearly spelled that out, right? And then again, R has a very, very rich help documentation as well. So everything has been explained with a lot of examples there, guys. Okay, so any other questions for me? Okay, so somebody has a question saying that how do I get machine learning using R? So when you look at machine learning, right? So it depends upon how much deep you want to get into machine learning. Machine learning, you'll have to also be very thorough with the concepts, etc. The implementation platform can definitely be your R, right? So R supports machine learning. So when you look at the supervised and the unsupervised and reinforcement learning, etc., you can do this. And as I mentioned earlier, you also have a tight integration with some of the languages which are definitely used for machine learning. For example, a Python. Python also has a very beautiful data visualization software, which is referred to as a bouquet, right? So if you're looking at Python, you can also look at Python and bouquet together. Python for statistical computation and bouquet for your data visualization. Likewise, it can be integrated with C Sharp, your Java, which is again very powerful, and also Ruby, etc. Right? So there, your machine learning concepts have to be delved into, right? So when we do machine learning, it's always AI and ML together, correct? So here we've mentioned about the case studies and the various scenarios. We've spoken about automation, etc. But first, be thorough with that concept and then get into the implementation part. So if you're asking me whether implementation is possible in R, yes, it is possible in R. Okay, so Rutuja has a question saying that which is more powerful, R or Python? R has, of course, become the de facto standard whenever people talk about statistical computing. But again, Python, people who are from the Python background can easily pick up R. Actually, guys, any programming language background, if you have, it is always very easy to shift to another programming language. So it's not about which one is better, R or Python. There are loyal followers of Python as well. And it also is dictated by several other parameters. So if you're working on a project, depends upon the client's preference, right? So if he wants it to be on Python, you do that in Python. If the person is asking you to suggest, then you can have a preference between R or Python, depends upon your convenience level, your comfort level with the language. Okay, so Nidhi has a question saying that how to implement linear regression using R. So Nidhi, just to answer your question, 2 points there. The first one, we have a chapter. I think chapter number 5 is on linear regression using R, not just the linear regression. We've also covered logistic regression. There are specific functions which are available in R. Just to talk about the linear regression, we have something which is called as LM. The LM function will help you perform the linear regression. So we've discussed the function, we've discussed the various parameters, we have explained the output. guys, a lot of emphasis has been given on explaining the output. It's not just that, we paste the screenshot, but you also have to understand what the output is all about. So something like an LM function, etc., for regression analysis, the output is not very obvious, right? So we have spent time explaining what the output actually means. Okay, so Neeraj has a question. So again, Neeraj, your question is specific to a tool. So he says that which algorithm of k-means clustering will give the similar output as SPSS? Now, guys, this is just for general information. We are not doing a tool comparison here. SPS is the first thing. It's an IBM tool and is a proprietary tool of IBM. So it comes with a cost, right? R is open source, correct? So you will have to explore more. Maybe there is no direct algorithm there, but a combination of algorithms will also work, correct? Okay, so Rohit has a question on where can you get data sets to practice using R. I'm going to mention a couple of data set sites which are free and for public viewing and public consumption. So you can look at the UCI site. There is also the KD Nuggets site where you will get enough and more number of data sets from various verticals. You have financial data set, you have data sets coming from the entertainment industry, from healthcare, and so on. So those are the two places that you can get your free data sets. R also comes with an N number of data sets, right? So you can also use that for exploration, correct? And if you are in any organization or in any of the colleges which collects data, so if they are okay with sharing that with you, you can also run your algorithms on it and come up with patterns, etc., which will prove useful to the management. Correct? So Rituja, here, of course, now for the paucity of time, we will not be discussing the various other algorithms, for example, hierarchical clustering, etc. But in the book, as I mentioned, we have an entire chapter devoted to clustering. So that we've spoken about the various other algorithms, apart from the k-means clustering, and we've also listed the pros and cons of each. Okay, Sanjay has a question saying that what will be the future of data analytics using R in the next 5 years? So guys, as per the Gartner Magic Quadrant, you can see that there is a lot of emphasis on analytics. So I will not delve deeper into it, but I'll just mention that the world is about predictive analytics. Gone are the days of descriptive analysis, correct? So descriptive was very easy because you do that on past data. Now is the world for real-time analytics. We are looking at whether the data will help you predict something in future. That's your predictive analytics. We have also gone a step further in looking at prescriptive analytics, right? Which means the optimization part. How well will you be able to leverage the situation that you are predicting for your own benefit or for the benefit of your organization? So predictive and prescriptive. We are done with descriptive and diagnostic analysis. That era is over, correct? So since we are stepping into predictive and prescriptive, and we have a lot of data, you have a lot of big data coming in for social media sites and stuff like that. We are overwhelmed with data, and that data needs to be analyzed. Not just 5 years. I think data scientists and the various other analysts and the various roles that we have around that area is going to stay in fashion for at least 15 more years, right? Again, if you need to look at the future of data analysts, etc., I'm going to suggest you one, I wouldn't say it's a company, it's a site actually, so you can go there and check it out for yourself. It's called as IDC, which is your International Data Corporation. So the trends, etc., can be watched there. Somebody mentioned about, whether R will replace SPSS. Guys, we aren't doing a tool comparison. Every tool has its own pros and cons. R being open source community, of course, the accountability is little less because who do you hold responsible if something doesn't work tomorrow? Nobody, right? So licensed tool will always have an advantage and they have their own loyal followers, correct? So it's not about comparing an R with an SPSS. If you have a complete IBM setup in a company, the advice would be to go to SPSS there. If you have a data stage for data warehousing, if you are using Cognos for data visualization, if you ask me for the statistical analysis, I would say go with SPSS. But if you have a choice and the company is a new startup, doesn't have any of the established platforms, then you can recommend an R. It depends upon several parameters. Guys, please remember budget is involved when you're looking at a platform, correct? So it is not about which one is going to replace which one. They're all going to exist together. It's going to be a coexistential living that you're going to see in future. Okay, somebody asked a question saying that is R having inbuilt function to define unstructured data? So Nidhi, I did mention about one chapter being devoted to big data. Big data has variety. It is all about structured, unstructured, and semi-structured data. So yes, the latest versions of R have a good amount of support for your big data as well, right? So for your specific needs, it's an open space, please explore. So guys, I think we have just about 3 or 4 minutes left. So in case you have any other question, feel free to shoot it out to me and I will take it up. Otherwise, we have very specific questions on whether it is good for this kind of analysis, etc. I am sure that you will explore on your own. Okay, so somebody mentioned about multivariate analysis. Yes, it can do multivariate analysis as well. So bivariate, multivariate, all kind of analysis are possible in R. So one of the places, somebody asked about the current project sector. Guys, we have a lot of work in the text mining space. We have a lot of work in the sentiment analysis space. People have analyzed the data which is coming in from Twitter and etc. to understand the sentiment, right? These days, people spend less time, going by what the salesperson is trying to say about their product, etc. They usually hook onto these social media sites of Facebook or Twitter to hear about what people are saying about the product, correct? So sentiment analysis is again a very beautiful thing that R has gotten into. So those are the current projects which are there in this area. Wherever you have data, you have to do analysis. And one way to do that is building up recommendation engines if you are a retailer and you would want to recommend products based on the past history of the transaction that the customer has had with your retail company. So Aditya had a question saying that can this be used with big data? I did mention yes, it can be used with big data, and you will find a chapter devoted exclusively to the big data and R together. Yes, a few MOOC courses are also available. People have mentioned about Coursera. Yes, there are courses available on Coursera. There are courses available on Udemy, etc., as well. But if you're one who would like a book to read and also a lot of practice examples, etc., you would want to check out the book. Okay, somebody have a question saying that can C++ be used for machine learning? Guys, just to answer that question, it is not about whether it can be used for machine learning. The question is about whether it is a preferable language for machine learning. So if it comes to preferable, whether it is preferable, it is desirable for machine learning or not, the answer is no. Either go for a Vivek had a question saying that which platform integrates well with R? Well, it is all the platforms. You can be on any of the OS and you will be able to exploit all the features of R. So guys, I think we are nearing the closure time. We have been talking for almost an hour. So this was just meant to give you an overview of what the book is all about and talk about a few features of R, etc. We've answered a few questions, and I'm sure that you will have a number of questions otherwise as well. So there are several open source community where you can get your queries answered as well. And you can always put in your feedback and your specific requirements to the macro community, and we will be in touch for this. Right? Thank you, guys. Thank you very much. I really enjoyed doing this session for you all. Thank you, and we will connect, and you can provide feedback for my book as well. Thank you.